Hello, I'm Venn Reddy. I'm a tutor for the DAE who teaches computer science, statistics, and math. And today I'll be covering indeterminate limits and how we can solve them using the Hopital's rule. Before we begin, there are three essential questions I would like students to focus on as they learn about this concept. One, what is an indeterminate form? Two, when can we use the Hopital's rule? What's the condition for using it? And three, what are the actual steps for using the Hopital's rule on a problem? Let's dive right into the first one. What is an indeterminate form? We use the Hopital's rule to evaluate limits of indeterminate form. What does that mean exactly? Well, there are two common indeterminate forms to look at. First is when you evaluate a limit or a function and you receive a numerator over denominator of the function or the form infinity over infinity. Here you can see that as we plug in infinity for our substitution, both the numerator and denominator will tend towards infinity. The other common form is when both the numerator and denominator tend to 0. Here, if I plug in 3 to the numerator, I would get 9 minus 9, which is 0. And for the denominator, 27 minus 27, which is also 0. Both of these are the common indeterminate forms that L'Hopital's rule is used to solve. Take note how these are not undefined, they're indeterminate. You cannot have an regular number over 0 because that would not meet the condition for L'Hopital's rule because it is not indeterminate. It must be of this form. Now, let's talk about how we use L'Hopital's rule. We use L'Hopital's rule on indeterminate limits by taking the derivative of the numerator and the denominator of the limit. So, if the limit as x approaches a, and a is some number of our numerator and denominator is indeterminate, then the derivative of the numerator and denominator as the limit of x approaches a must equal that same limit as x approaches a. This might look a bit confusing at first, but the main important thing to realize is that if you get a limit that evaluates to infinity over infinity or 0 over 0, we can take the derivative of the numerator and denominator to hopefully simplify the limit to not get an indeterminate form when we substitute again. That's what L'Hopital's rule is. Let's see how we use it. I'm going to take a look at the indeterminate limit from the beginning, where we had the limit as x approaches infinity of x squared minus 6x over x cubed plus x squared plus 2. Here we know that once we substitute, we would get an indeterminate form with infinity, as we just saw above. So the condition for the indeterminate form has been met, and we can use L'Hopital's rule on it. So the first thing I'm going to do is take the derivative. And I encourage people trying at home to also do this as they go along with the PowerPoint. Here I've taken the derivative of the numerator and denominator. And we can see that that simplifies down to 2x minus 6 over 3x squared plus 2x. Hopefully that makes sense. That was a pretty simple derivative to take. Now, I'm going to take the derivative again, because if we plug in infinity here, we would still get the numerator tending to infinity and the denominator tending to infinity. So that also meets the rule for an indeterminate form. So we have to just take L'Hopital's rule again, just take the derivative again. Once again, I'm taking the derivative. The numerator is going to be 2 and the denominator is going to be 6x plus 2. Now we know that our limit evaluates to 0 because we have a number tending towards infinity at the bottom and a constant divided by a really large, almost infinite number is going to be essentially 0. And so that's what our limit evaluates to. So here we had to take L'Hopital's rule twice, take the derivative of the limit twice, in order to simplify to a form where we could substitute it and not get an indeterminate form. We could substitute it and get 2 over infinity, which is basically 0. Now I'm going to take a look at the second indeterminate limit from the beginning. The limit as x approaches 3 of x squared minus 3x over x cubed minus 27. Here we saw that that evaluates to 0 over 0. So the indeterminate form is met, and we can use L'Hopital's rule on it. So, as always, I'm going to take my derivative, and we see that the numerator simplifies to 2x minus 3, and the denominator simplifies to 3x squared. Hopefully, again, that's a simple enough derivative for y'all to understand without going into extra steps. Now that I've gotten to this point, I'm going to try plugging in again my substitution method, and we can see that I can actually substitute now without getting an indeterminate form. So I would get 6 minus 3, which is 3, over 3 times x squared, so 3 times 9, which is 27, which simplifies to 1 over 9. And as before, the main process, the main idea, was taking the derivative of the top and bottom, because we had an indeterminate form, to simplify it to a state where we could substitute and get a constant as an answer. In conclusion, we know that we can only use L'Hopital's rule when dealing with limits of indeterminate forms. So if you'll remember our essential questions, what is an indeterminate form? It's a form of 0 over 0 or infinity over infinity. For the most part, there are some niche cases. And we use L'Hopital's rule only when we have a limit of that form. That is the condition. That's EQ2. If we try to use that rule in a limit that does not resemble that form, it will break down. It will not work. And in terms of how to actually use it, again, as we covered, you take the derivative, and we can see some good examples of when we can use L'Hopital's rule and the condition being met versus when we shouldn't use L'Hopital's rule because the condition is not being met. Hopefully, that was a helpful review and that helped you all to understand what L'Hopital's rule is and what indeterminate forms are to help you with limits in calculus. Thank you so much.